you two champions, your chemistry examination is on 9th of March. So only 2 days are left for your preparation. So in this video, we are going to discuss the most important and repeated questions from all the chapters. So if you just want to pass this examination, then this video is for you. So from all the chapters, all the important questions I have picked up, which has been asked in previous year and model question papers. So if you watch this one video and practice all its important questions, then you can definitely pass this examination with a decent score. So let's get started with our first chapter, that is solutions. So the first chapter, first question is state Henry's law and write its mathematical form. What is the significance of Henry's constant? So whenever a law is asked, make sure that you write as it is given in the book. So Henry's law states that at a constant temperature, the solubility of gas in a liquid is directly proportional to the partial pressure of the gas present above the liquid of the solution, and P equal to kH of the gas, and here we have the terms explained. And what is its significance? Whenever there is a larger value of kH, the solubility of the gas decreases. Now going to the next question, state and explain Raoult's law of the liquid solution. So Raoult's law states that for a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to its mole fraction. Now P1 equal to P01 x1, and here are the terms given with their meanings. So before moving ahead, KCT 2026 examination is closer, and if you really want to crack this exam, you have to not only complete the syllabus but also write test, and you also need to analyze your preparation, and for that a test series is very important. So to help you with this, we have launched the Fighter KCT 2026 test series, which is based on KCT exam pattern and syllabus and is designed by KCT experts. Now here you will get total of 18 full-length mock tests, 6 each from physics, chemistry and maths, detailed solutions, video solutions for chemistry, and most important, a detailed analysis report after every test to know your strength and weak areas. Now the best thing is all these things are available at a very affordable price of just rupees 399. So click on the link given in the description section and purchase it right now, as the prices may go higher later. Now moving to the third question is state Raoult's law of relative lowering of vapor pressure. So here there's a slight change. It states that in a solution containing a non-volatile solute, the relative lowering of vapor pressure is equal to the mole fraction of the solute in dilute solutions. So here actually P01 minus P1 by P01 is equal to XP. Now difference between ideal and non-ideal solution: obeys Raoult's law, do not obey Raoult's law. Delta V mix H mix 0, not equal to 0. AB interactions are equal here. Here AB interactions is greater or lesser than AABB. Examples are very important, so you have to learn these examples. Next is the difference between positive and negative deviation. Here AB interactions are weaker, here AB interactions are stronger. PA is greater than P0A XA, here PA is less than P0A XA. B mix H mix greater than 0, here it is less than 0, and here are the examples that you should remember. Next we have what is azeotropic mixture, mention its types with examples. So binary liquid mixture having the same composition in the liquid and the vapor phase and boiling at a constant temperature are called as azeotropes. The minimum boiling azeotrope, so in this, the solution has a lower boiling point than either of the components, and in maximum boiling azeotrope, the solution has a higher boiling point than either of the components. Then it is formed by positive deviation, it is formed by negative deviation, and then here you have examples of maximum and minimum boiling azeotropes. Next is important graphs. So the first one is regarding the Henry's law. Okay, next we have for the ideal solutions. Then this one is for positive deviation, and this graph is for negative deviation. Next important graph is for elevation in boiling point. This is depression in freezing point. Okay, depression in freezing point. And the third diagram, if reverse osmosis is asked, then you have to draw this diagram. Next, we will see some important formulas here. So, relative lowering of vapor pressure, XB equal to P0 minus P by P0. Then delta TB equal to KB into molality. Delta TF is equal to KF into molality. Osmotic pressure pi is equal to C into R into T. Next, we have important formula for molarity, molality and mole fraction. Moving to the next chapter, electrochemistry. The first question is state Faraday's first and second law and write its mathematical expression. So Faraday's first law states that the mass of the substance deposited or liberated at an electrode is directly proportional to the quantity of electricity passed through the electrolyte. Okay, M is equal to Q, or M is equal to Z into Q. Next, Faraday's second law is when the same quantity of electricity is passed through different electrolytes, the masses of the substances deposited are proportional to their equivalent weights. M1 by M2 equal to E1 by E2. Next, what is Kohlrausch's law and what are its applications? So at infinite dilution, the molar conductivity of an electrolyte is equal to the sum of the limiting molar conductivity of its constituent ions. Next, we have what is metallic conductor and electrolytic conductor. So here the conduction is due to the movement of electrons. Here it is due to the movement of ions. Next, it can be conduct electricity in solid state. Here it can conduct only in fused state or in the solution state. Here there is no chemical reaction. Here chemical reaction takes place. Conductivity decreases with the increasing temperature. Conductivity increases with the increasing temperature. Metals do not decompose, electrolytes decompose. And then here we have examples. Next, we have primary battery. Here the reaction occurs only once, and in secondary cell the reaction can take place again and again by recharging the battery by passing the current in it through opposite direction. And then you have examples. Next is the diagram of the neat level diagram of Daniell cell. This is the diagram you have to draw. Write its symbolic representation and overall cell reaction. So the overall cell reaction is like this, where zinc undergoes oxidation and copper undergoes reduction. And if you just want to write the cell notation, it is like this, Zn to Zn2 plus, then you have copper 2 plus 2 copper. Also write their physical state here. Okay, yes. Next, we'll move to describe the construction of SHE, that is standard hydrogen electrode. So here, first of all, there is a platinum rod painted with platinum black, dipped in 1 molar solution, and here hydrogen gas is passed through 1 atm pressure. Then the temperature is maintained at 298 Kelvin. Okay. Next, we have the reaction of electrode at so H plus 2 electron gives you H2, and here is the anode and cathodic reaction, and it's, I can say, the value of this one, the standard reduction potential of hydrogen electrode is assumed to be 0. Next, hydrogen oxygen fuel cell diagram, and this is the anode, cathode and the overall cell reaction. Next is direct measurement of conductivity of ionic solution through Wheatstone bridge is not possible. Give reason. So the first reason is here direct current is used, and the second reason is you cannot use solutions directly in the Wheatstone bridge. What is the problem solution here? You can use AC current instead of DC current, and the electrolytic cell can be kept in and conductivity cell is used to connect it to the Wheatstone bridge. Next, explain the variation of conductivity and molar conductivity with dilution. So conductivity always decreases with dilution. That is because the number of ions decreases per unit volume, and molar conductivity increases with dilution. For weak electrolyte, it increases because of the increase in dissociation, and for strong electrolyte, it increases because of the increase in the mobility of the ions. Now you can see the diagram here. This is for strong electrolyte, okay, and this is for your weak electrolyte. Clear? Next, we have what is corrosion, and explain corrosion as a electrochemical phenomena. So here at anode, Fe undergoes oxidation, and the electrons reduced here are used to reduce oxygen. So this is how the reaction takes place, and this is the overall reaction of rusting. And this Fe2 plus further gets oxidized to form hydrates of oxides of iron, which is called as your rust. Next, we have electrochemical cells and their reactions. So dry cell, mercury cell, these reactions are important, but the most important one which you have to remember is your lead storage battery reaction. So in anode reaction, lead gets oxidized to Pb plus 2, and here lead gets reduced to from Pb plus 4 to Pb plus 2. Next, here are the important formulas: R equal to rho into L by A, rho equal to R into A by L, G star is equal to L by A, G equal to 1 by R, conductivity value is equal to 1 by R into L by A. This is the most important formula, and molar conductivity kappa into 1000 by C. Now moving to the next chapter, that is chemical kinetics. What is the difference between order and molecularity? So order is the sum of the powers of the concentration terms in the rate law, whereas molecularity is the number of reacting species in the elementary step. Then it can be 0, fractional or an integer, and this can be a whole number. That is determined experimentally, it is determined theoretically, and applicable to both elementary and complex reactions. It is applicable only to the elementary reactions. Next is the derivation of zeroth order law. This is an important question, very, very important question. So first of all, you have to assume any reaction R gives you P. Okay. Then according to the rate law, we have rate is equal to minus dr by dt, and rate is also equal to k into r to the power of 0. So equating this, we will get this equation. So rate is equal to minus dr by dt is equal to k. So I will now just consider this part of the equation. Now I can write dr is equal to minus k dt. Now I can take integration on both sides. That will give me r is equal to kt plus I. Now I is the integration constant. When t equal to 0, r is equal to r0, you can find the value of I as r0. Okay. Now you can substitute this one here and you will get r equal to minus kt plus r0. Moving to the next one, derive the integrated rate law for first order equation. So we have minus dr by dt is equal to kr. Now if I do cross multiplication, minus dr by r is equal to k dt. Now minus dr by r, you will get minus ln of r is equal to kt plus I. Now here I value at t equal to 0 and r equal to r0, I will get I equal to minus ln r0. Now if I substitute this value, you will get ln of r0 by r is equal to kt, and that is equal to 2.303 by k log of r0 by r. Next we have integrated rate law for first order for gas phase reaction. So if you have a reaction like this, A gives you B plus C, and consider all of them are gases. So at T equal to 0, P1 is the pressure of A, 0 and 0 are the pressure of B and C. Now X amount of A has reacted, so A pressure is now P1 minus X amount of B is formed, so X ATM, and C is also X ATM. So what is the total pressure here? The P total is equal to, I can say, P1 plus X. So what is the value of X here? Pt minus P1. Okay. Now we will substitute. Now you can see that initial pressure of A is P1. Now this X value, how much I have calculated? X value, so pressure of A at time T is P1 minus X. So that is P1 minus X, but X value is Pt minus P1. So substitute that here and you will get 2Pi minus Pt. So the pressure of A at T equal to 0 is P1, and the pressure of A at time equal to T is equal to 2Pi minus Pt. So that is what you have to substitute here and you will get this equation. Okay. Next is half order, how to derive the expression for half order. So for a zeroth order reaction, we know the value is A0 minus A is equal to Kt. For half order, T equal to T half, and I have A equal to A0 by 2. Okay, now I can substitute here. So I will get A0 minus A0 by 2 is equal to K into T half. Okay, so 2A minus A0, I will get here this one. So I can just substitute here. 2A0 minus A0 by 2 into K is equal to T half. So I will get here A0 by 2K. Okay. Now for moving for the first order reaction, T equal to 2.303 by K log of A0 by A. Okay. Again you substitute here, that is equal to T half 2.303 by K log of A0 divided by A0 by 2. That is 2.303 by K log of 2. That is 0.693 by K. Okay. Next we have Maxwell distribution curve. So this is the diagram, fraction of molecules on the y-axis and the kinetic energy on the x-axis. And if you see that, if you mark somewhere, here is the activation energy. Next is for effect of temperature. You have to draw this graph. You can see as we increase the temperature, the number of particles having energy greater than the activation energy increases. Next, these are some important graph for zeroth order. These are two for first order. You have to see what is given in the question and then draw the diagram accordingly. Next, Arrhenius equation in linear form. This is the diagram. Next, what is pseudo first order reaction? Is those reaction which is actually a second order but it appears to be first order because one of the reactant is present in large concentration. Here are the two examples. Next, some important formula. First, integrated rate law for first order, then Arrhenius equation and the T half for first order. Next, we'll move to D and F block chapter, difference between lanthanoids and actinoids. So here the question can also be asked like write the properties of lanthanoids or write the characteristics of lanthanoids. Then also you can write down only the points of lanthanoids. Okay. So electrons enter into 4f orbital. Here it enters to 5f orbital. They are non-radioactive. They are radioactive. Binding energies are higher here, lesser here. Less basic, more basic. Higher oxidation state is +4. Here it is +7. 4f has more shielding effect compared to 5f. Lanthanide contraction is lesser, here actinide contraction is greater. Next is the balanced equation for the preparation of K2Cr2O7. So first iron chromate is converted to sodium chromate is converted to sodium dichromate, then sodium dichromate is converted to potassium dichromate. This is one of the most important question. Okay, so you have to prepare these reactions with the balancing. Next, the question can also be asked in the form of this particular word problem, then also the answer remains the same. Next is the preparation of KMnO4. So here first MnO2 is treated with KOH and O2 to give you K2MnO4. Then K2MnO4 under electrolysis gives you KMnO4. Next was to calculate the magnetic moment of titanium 3+. So if you see titanium 3+ configuration is D1. So what is the magnetic moment formula? Root over of n into n plus 2. Here n value is 1. So I'll get root over of 1, which is 1.732. Unit is important, Bohr magneton. Next, transition elements form colored compounds because they have unpaired electrons which can undergo DD transition. Next, catalytic activity. Here they have variable oxidation state, large surface area and presence of incompletely filled d orbital. Complex formation, smaller size, larger ionic charges and availability of d orbitals. What is interstitial compounds? Are those compounds which are formed when small atoms like hydrogen, carbon, nitrogen are trapped in the crystal lattices of the metals. They are usually non-stoichiometric. Examples are here and they are hard, high melting point, retain conductivity and are chemically inert. Next, alloy because of similar radii, and these are the examples. Now let's move to the next chapter, that is coordination compounds. The first question is to write the postulates of Werner's theory. This is very important question. So the first point tells that the coordination compounds have primary and secondary valency. Primary valencies are ionizable and are satisfied by negative ions. Secondary valencies are non-ionizable and are satisfied by neutral or negative ions. Next is difference between double salt and coordination compounds. It loses its identity, doesn't lose. No coordinate bond. Here we have coordinate bond. It is stable in solid state. It is stable in solid as well as in aqueous state. Shows normal valences. It shows primary and secondary valency. Next is a valence bond theory question. So I'll be explaining one and others you can check accordingly. There are 4 compounds in the NCERT. Any one of these 4 compounds will be asked in the examination. So CO NH3 F6 3-. So cobalt is in +3 oxidation state, that is D6 configuration. F is a weak field ligand, so no pairing of electrons. So this sp3d2 orbitals undergo hybridization to give you 6 sp3 hybrid 2 orbitals, where the fluorine can donate the electrons to form an octahedral geometry. And since the metal has unpaired electrons, so this is paramagnetic in nature. Similarly, you have for CONH3 NiCl4 and NiCN4. You have to practice these 4 compounds. Any one will be asked in the examination. Next is the diagram for d orbital splitting for octahedral. So T in Eg there are 2 orbitals. T2g goes down, which is having 3 orbitals. Next we have haloalkanes and haloarenes chapter. The first mechanism question is on SN1 mechanism. So there's a formation of carbocation first and then there is the attack of nucleophile. So here you have 2-chloro 2-methyl butane getting converted to 2-methyl butane 2-OL. Next, SN2 mechanism. Here OH minus gets converted, forms a structure like this, transition state, and that gets converted here. Next, we have Sandmeyer reaction. Here what happens, aniline first gets converted to benzene disonium chloride, which reacts with the salts of copper to form aryl halide. Next, we have Finkelstein reaction. So Rx plus NaI gives you Ri plus NaX. Alkyl iodides reacts in presence of, so alkyl halides reacts in presence of sodium iodides. Next, we have Schwarz reaction. So here alkyl bromides or chlorides reacts with metallic fluorides to give you fluoroalkane. So you have to learn this statement and this example. Next, Woods reaction. Here alkyl halides react in presence of sodium and dry ether to give you compounds having carbon double the number of the initial compound. So if I have 2CH3Cl, it will react with sodium and dry ether to give you CH3 plus 2NaCl. Okay. Next, we have Wurtz-Wittig reaction. So here when alkyl halide and aryl halide reacts in presence of sodium dry ether to give you Wurtz-Wittig reaction. Next, we have only Wittig reaction. So aryl halides when treated with sodium in dry ether reacts to give you diphenyl. This is called as Wittig reaction. Now here are all the electrophilic substitution reactions of haloarenes. So you have to prepare this reagents and all. So just go through these reactions. Next, we have alcohols, phenols, and ethers. So first mechanism based question, which is very important, is the dehydration of alcohols to alkenes. So first of all, the step 1 is the protonation of alcohol, and then there's a detachment of water to give you a carbocation, and then there is an elimination reaction to give you alkene here. Next reaction or mechanism based question, very important, is alkenes to alcohols. So here we have first of all alkene, it gets protonated and a carbocation is formed here. Then the water molecule attacks on this carbocation so that a water molecule is attached, and after that there is deprotonation to give you a compound like this. Next, we have Coles reaction. So here phenol reacts with NaOH to give you ONA, and presence of CO2 and H plus forms the 2-hydroxybenzoic acid or salicylic acid. Riemann-Tiemann reaction, you have phenol with CHCl3 and aqueous NaOH. It reacts to give you finally salicylic aldehyde. So you have to remember the statement and the reaction. Next, we have Williamson ether synthesis. Here one haloalkane and an alkoxide ions react to give you a ether. Okay. Next is cumene process, very important. So here first of all isopropyl benzene is taken. It is reacted with oxygen to give you a compound like this, cumene hydroperoxide, and then the product formed here is acetone plus phenol. Next, we have what is Lucas reagent. So Lucas reagent is a solution of anhydrous zinc chloride in concentrated hydrochloric acid. And here, if you know, tertiary will react immediately, secondary will react after 5 minutes, and primary will react not at all, will not react, sorry. Okay, so that is how Lucas reagent can be used to distinguish between tertiary, secondary, and primary alcohols. And these are the electrophilic substitution reactions of phenols. You have to definitely remember at least these reactions. Moving to the next chapter, aldehydes, ketones, and carboxylic acid. The first mechanism based question is your addition of HCN to carbonyl group. So here CN will attack. So first of all, there's a generation of nucleophile, then the CN will attack, and then there is a tetrahedral intermediate is formed, and then finally you will get the cyanohydrine product. Next, there are a lot of name reactions in this chapter, so you have to remember all the name reactions. Rosenbaum reaction, so whenever any acyl chloride is treated with hydrogen and palladium barium sulfate, this chlorine is replaced with hydrogen. Stefan reaction, whenever you have nitriles with SnCl2 and HCl, you get an imine which on hydrolysis gives you aldehyde. Next, Itard reaction, when you have toluene, you react with CrO2, Cl2 and CS2, you get a complex of chromium which under hydrolysis gives you benzaldehyde. Next, when you have benzene, CO and HCl anhydrous AlCl3 CuCl, that gives you benzaldehyde. Next, we have again Clemmensen reduction. When you have ketone, treating it with zinc, mercury and HCl, you get CH2 group plus water. So this is reduction of ketones to alkanes. Next, you have again Wolff-Kissner reduction. Here also you have this particular compound. If you treat it with NH2 forms an imine, then there is reduction using ethylene glycol to form a compound like this. Next, what is Tollens reagent? It is the freshly prepared ammoniacal silver nitrate solution, and it is used to test aldehydes. Cannizzaro reaction, so those compounds which do not have any alpha hydrogen, it undergoes self-oxidation and reduction with the presence of concentrated alkali. So if you see, this is formaldehyde at concentrated KOH. On heating, you will get methanol and sodium salt of potassium salt of methanoic acid. HVZ reaction, again very important reaction here. So compounds having alpha halogen group, okay, in treating with X2 and red phosphorus, you get a product where you have alpha halocarboxylic acid. Next, aldol condensation, aldehydes and ketones having at least one alpha hydrogen undergo reaction in the presence of dilute alkali as catalyst to form beta hydroxyaldehydes or ketones, which on heating produces alpha beta unsaturated carbonyl compounds. Okay, this is also important name reaction. Next, haloform reaction. So compounds having this methyl ketone group, on reacting it with NaOX, okay, it forms compounds with one carbon less, that is CHX3. Okay, so sorry, this CH3 group gets converted to CHX3 and this part gets converted to the salt. Next, we have amines chapter. So first of all is your Gabriel phthalimide reaction and its equation. This is important question. It is used to prepare primary amine. So first of all, here we have amine group. With KOH you get a salt, then with RX you get NR, then there is treatment with NaOH, this breaks here and you get a compound like this. Hoffman bromamide degradation, amides on heating with bromine and aqueous NaOH gives primary amines having one carbon less. So RCONH2, that CO group gets detached and you get RNH2. Carbylamine reaction, when primary amine is heated with chloroform and alcoholic KOH, it gives isocyanide. Okay, so RNH2 with CHCl3 plus KOH gives you RNC. Next, we have what is Hinsberg reagent. So this benzene sulfonyl chloride is Hinsberg reagent and it is used to differentiate between primary, secondary and tertiary amines. So with primary amines, you will get sulfonamide salt and this particular salt is soluble in alkali. With secondary amines also you will get a salt which is insoluble in alkali, and with tertiary amine there is no reaction at all. So you can see here primary amines give N-alkyl benzene sulfonamide soluble in alkali. Secondary amines gives N dialkyl benzene sulfonamide insoluble in alkali, and tertiary amines do not react at all. Next, Gattermann reaction. So when you have benzene disonium chloride with copper powder and HCl or copper powder and HBr, you get ArCl or ArBr. Next, this is important basicity order you should remember. In gaseous phase, tertiary, secondary, primary. In aqueous phase, okay, this 2R is for aqueous phase. In aqueous phase, if R group is methyl group, then you have 2, 1, 3, means secondary, primary, tertiary, then ammonia. And if you have ethyl group, it is secondary, tertiary and primary if it is a ethyl group and ammonia. Then NH3 is more basic than aniline because in aniline there is resonance. And because of resonance, what will happen? The lone pairs of electrons will move in the ring and are not available for donation. Moving to the last chapter, biomolecules. The first difference between you should know is amylose and amylopectin. It is water soluble, water insoluble. It contains 15 to 20% of starch, contains 80 to 85% of the starch. Unbranched, this is branched. It is made up of alpha D glucose C1 C4 linkage units and alpha D glucose units in which C1 C4 glycosidic linkage and C1 C6 branching linkage is there. Next, fibrous and globular protein. Here polypeptide chains run parallel to each other and are held together by hydrogen and disulfide bonds. Here polypeptide chains coil around to give a spherical shape. Insoluble in water, soluble in water. Keratin and myosin. Here we have insulin and albumin. Okay. Next is glycogen and starch. It is found in animals, found in plants, highly branched, less branched, stored in livers, and it is stored in seeds and tubers. Difference between RNA and DNA, it has a double-stranded, single-stranded. Sugar present is beta D2 deoxyribose. Here we have beta D ribose. And the nitrogenous bases are adenine, guanine, cytosine, thymine. Here you have uracil. It replicates, does not replicate, controls the transmission of genetic information. It is mostly important for protein synthesis. Large molecular mass here and it has relatively low molecular mass. Next, how the structure of glucose is determined. This is very, very important. Here the question can be like which reaction shows that so I will be telling you the conclusion as well. So see here the question like this: when glucose reacts with HI, it forms N-hexane. Now this reaction shows that glucose has 6 carbon in one chain, means linear chain. Okay, 6 carbons in linear form. So the question can be, write the reaction which shows that glucose has 6 carbons in the linear form. Then you have to write down the reaction with HI. Similarly, reaction with NH2OH or HCl shows the presence of carbonyl group. Okay, shows the presence of carbonyl group. Okay, so NH2OH and CHO. Next one, reaction with bromine or water. What does this reaction shows? It shows the presence of, so carbonyl group means what? We have both aldehyde and ketone, but with bromine water, with the presence of formation of gluconic acid, it confirms the presence of CHO group, means aldehyde group. Next, the fourth one, reaction with this anhydride, it shows the presence of 5 OH groups. Okay. Next we have this one, reaction with HNO3 or nitric acid. This one confirms that out of that 5 OH groups, one of the OH group is primary. Okay. So this is how you should remember which reactions give us what conclusions and what are those reactions. Next, the structures are very important. The first structure is of alpha and beta gluco, alpha D glucose. Diagram based questions will be more from this chapter, so you should remember this structures. Okay. Next you have alpha and beta D fructose. Next here it is the structure of sucrose, maltose, lactose, amino acid structure. Then how the peptide bond is formed, especially this particular example, glycine and alanine, or how the structure is formed, how the peptide bond is formed. Next, the vitamins and the deficiencies. This is a very, very important question. So at least in MCQs and all, this type of questions can be asked. So vitamins, their sources and their deficiency diseases, you should remember. Okay. Now, if you just want to pass the examination, the first thing you need to do is to prepare all the questions given in this video, all the reactions, diagrams, formulae, and the tables that I've given you. First prepare this much, then I'll be giving a numerical video, so just make sure that you practice all those numericals. So from here 9 marks you will definitely secure, and practice the questions of the model question paper. Okay, just go through all the questions of the model question paper. Most of them will be repeated, there will be slightly different questions, but yes, if you have done these questions, numericals, then you can easily attempt the model question paper, and I'll be making a video where we'll be solving all the model question paper questions. Okay, so students, that's all in this video. And before leaving, as I have already told you, the KCT 2026 test series is live, and the link is there in the description section. You can purchase it at a very, very affordable price of just rupees 399. So please hurry up. And yes, so many other videos are going to come for your chemistry preparation. So if you haven't subscribed the channel, do it. And thank you so much. All the best. Keep learning and keep working hard.